rate of annual return. So because we use compound measure of return, compound rate of measure for return. For the return, right? And again, right, from the beginning period to the ending period. In other words, from the beginning value to the ending value. So when you have to measure that, you measure using that entity. All right. So when you have to measure, we are looking at that geometrical mean is one of the long-term performance measure. It's a long-term performance measure for an investment. Measure for the investment. And again, this is one of the superior measure for, it's a superior measure, all right? It's a superior measure. And again, we are saying that it is one of the superior measure because we use the compound rate of measure. It's a compound rate here. Compound rate. Using beginning value and ending time. All right, specifically using the prior examples, the former one, if we compounded 3.3%, if you go to that one, 3.3%, which is 3% for 3 years, we would get an ending wealth value of 1.104. If you look at 1.104, that is ending wealth value. So what is that? 1.104. When you look, if you go back, that example that you learned last week, oh no, it was when? Yesterday, you learned that it was, we had 1.104, and it was what? Yeah, but what was that? Before we come to the part 3, we actually said that this is the holding period return. So this is the HPY. Holding period return towards this. Because when you minus 1, it is holding period yields. So when we talk about holding period return minus 1, what we are getting is the holding period yields. Therefore, this is 1.104 subtract 1, you are getting 0.104, which is the same as, what is that? The same as what? This is equivalent to 10%, right? So this is 10 what? 10%, 10.4%, right? This is the HP. This is the 10%. So what is this 10%? When you look at the 10%, this is the HPY, right? Yes. HPY is this one. Are we together? Yeah, HPY is this one. All right? Assuming that we haven't written the power. Because the moment you put a power here, it means now you have for the 3 years, right? So let's go for 3 years. For 3 years, let's go for 3 years. For 3 years, what was that? It was 1.104 to the power what? To the power 3? 1 over 3. So it's 1.104 to the power 1 over what? 3. All right? Which is the cube root, right? Cube root of 1.10 what? 4. All right? And what is the answer? 1.0335, something like that, right? Which is, so you take this one minus 1, all right? So minus 1, this gives you 0.33, 0.033 what? 5. which is the same as 3.35%. Right? What is this one we have calculated? This is HBY. Right? Right? Yes. We are looking at this. All right. Now, what is happening there is, although arithmetical average provide a good indication of expected rate of return for the investment during future individual years, it is biased upward if you are attempting to measure the asset long-term performance. All right, let's look at this. Let's go to arithmetical mean here. If you look at this arithmetical mean, although arithmetical mean is a very good measure, it's another good measure for the investment for a long period of time. But the disadvantage of using this is that it is biased, especially upwards. So it is biased upwards. Bias upward. So the arithmetical mean is bias. It seems it's a very good measure, but yes, again, it is bias upwards. It is bias upwards. Now, when you look at that, it is bias upwards. Let's go to especially when it's bias, when you look at an asset long-term performance, that's why it is bias upwards. We'll look at it, why is it that it's bias upwards in terms of long-term performance. That one is simply because we are looking at it because of for the reason being what is called the volatile security. We are referring at this issue of volatile security. They are saying that the reason being it is bias upwards simply because it is one of what is called a volatile security. So it is what is called a volatile. It's a volatile security. We'll look at this word. What do you mean to say that this is a volatile security? All right. So we talk about a volatile security. Let's go back. If you look at that one, a volatile security, all right, it's a security that increases its price. You look for the first year, you are increasing the price from 50 to 100 first year, and you drop to 50, and then so that is what is called volatile. When you look at the issue of volatility comes in when you invest 50, you get 100, and then you are going back something. That is what is called volatile security, a security that increases price and then decreases, so it drops. So that is what is called volatile security. Let's define this word volatile security. A volatile security, we'll talk about volatile security. All right, volatile security, it is a security that increases its price and it decreases in the other year. So it increases its price, it increases its return, all right, increases its price, very good, and then it drops the other year for that year, and it drops in the following year. For example, you're looking at this is a volatile security. Volatile security, it goes like that and it goes like that. So you're looking at volatile security, like you are looking at year 1, all right, year 1, year 2, all right. So beginning value 50, ending value 100. HBR is equal to 2. You divide. HBY is equal to 1. Okay, then because this one again, you are taking this one 100, then it drops to 50. HPR 0.5. HPY minus 0.5. All right, which is negative 50%. This is 100%. All right. Now, when we talk about volatile, what it means is you deposited the share, you got the shares 50 share, you got that, and at the end of the year, you got 100 double. All right, which is 100%. All right. Then the other year, you maintain 100, and you are obtaining 50. It's a loss, which is 0.5, which is this one negative 50%. That is so. The issue, what is happening here? What is happening here is what is called the volatile security. So volatile security is happening here. Volatile security is happening here. Volatile security is happening there. All right. Now this would give an AM rate of return. If you go to that, let's go to AM rate of return. Let's find AM and GM for that. Can you find AM and GM for this? Let's calculate AM and GM for that. Let's calculate AM and GM for that. How do you calculate AM and GM? AM. What's the formula for AM? Summation of HPY. Divided by N. Like this one, right? Right. So let's find HPYs. HPYs are. Let's HPY. HPY 1 plus 1 plus minus 0.5. So this is 1 minus 0.5, which gives you 0.5. All right. I said, what is this? 1 HPYs. That's what I say. Formula is coming here. HPYs, right? It's 1. We are using this table. 1 plus this, like a summation. 1 plus negative this one is this one. 1 plus negative this one, right? That's why negative, positive, negative, negative, right? So the same as 1 minus this one, right? Which is 0.5. And this is 50 what? 50%. Eh? Clear? Divided by N. All right. Divided by what? N. So it is 0.5 divided by how many is? 2. And this gives you 0.25, which is the same as 25 what? Percent. This is your arithmetical mean. The meaning is that for the 2 years, what is happening there? The arithmetical mean is 25%. We will define what is that. Let's go to geometrical mean. Let's go to geometrical mean. GM is equal to HPR the power 1 over N minus 1. Okay? How do you do that? So this is multiplication HP. So it's HPR. You have HPR 1 multiplied by HPR 2 multiplied by HPR. We are defining this. All right. So what do? You multiply HPR1. HPR1 is this one, right? You multiply by this one, right? So it is 2 times 0.5, and the answer is 1, right? The answer is 1. Okay. And this 1 to the power 1 over 2, which is the same as square root of 1. All right. So the square root of 1 is what? 1. Square root of 1 is 1. All right. And then it is 1 minus 1. So 1 minus 1, the answer is equal to what? 0. So this is 0%, right? This is 0%, right? So what is this 0%? So the 0% there, what we are looking at is, let's go to this one. You deposited here the 50, you got 100 first year. He took the same 50, then he's giving this. What advice would you give to this guy? He bought 50 shares. He bought shares and got 50. He got shares, got 50. And then he got 100, right, as the dividends. Then you are advising this guy as your manager, take this 100 and you deposit again. And he's getting 50. What advice would you give? What advice? Should he continue or she should stop? They can diversify to another investment because he hasn't done any profit at all. If you look at that one, he can, because if you tell this guy to take again 50, putting it there, we don't know what will happen. There are a lot of things that you can have, maybe economy, what is. There are a lot of things that are happening to shares. But when you look at the way it is, and if the guy diversify to other investments, that would be, to have several investments, I think that would have worked. All right, we are just assuming that if he does that, that would have been much better. Because when you look at what is happening, we are saying, based on what we have written, we are saying that AM and GM, the best measure that you have to do is the GM. So the geometrical mean, the best measure you have to do to work out, it is this one. This is very superior here. All right, 0%. Unlike this one is giving you, but again the problem with this is bias upwards. So it is bias upwards. The fact that it is bias upwards, that's why we are saying the issue of volatility comes in. Volatility is coming in because of that. Now, this is bias upwards. But this one can be a very good measure. That would have been a very good measure. Let's proceed. Let's proceed. Let's proceed. The answer of 0% rate of return actually measures the fact that there was no change in wealth from this investment over 2 years. Right? The issue of 0%, actually it is telling us that there was no change. It was constant. What if that was if he had losses? If he had losses, this would have been negative. Right? But because it was constant, that's why it was like this. If it is a profit, this would have been positive. Yes, more than 0. All right, but because there was nothing, that's why this was like 0. But if it was losses, this would have been negative. All right, you can try putting losses there. Work out losses. You can try making losses. That this guy invested 50, he got 100. So he had the same 100, but here is given to 25. Is given, or if he is given 75, is that again loss? 75. He was getting 50. Try if he is, try here, work out, put A 70, B he invested 100 and is getting 20. Work out that. Find out AM and GM. Here. Work out AM and GM for this one. Here. Huh? Up. He had 50, he got 100. 100 investing is getting 70. Work out here. Then is getting 20. Work out here. All right? Yeah. Because from there is where we are going to make our decisions here. I want you to work out. What I want you to do is find HPR, HPI, then work out geometrical, arithmetical mean, and work out geometrical mean, and then compare the two. No problem. No problem. Abakari 70. All right? Let's put here 7. A, put here 70. B, put here 20. He got, and then put here 10. All right? What to say? It's not a test. You can be helping each other. It's not a test. Wherever you can be sorting each other together, no problem. Yeah, we can sit together and help each other. Yeah. You are done? This is investment, eh? Sign here. Just sign here. Yeah. Yeah, just sign there. Oh, go to the date. What's the date today? 22. 23. 23. Hello? Nili bendera amatu nalina bwina nangu otutumizira ya nkongole besi ndifalina kwatumizira yonse. Ndi yasa je ntumiza. Yasa je ntumiza. You are done? You are done? Hmm? Now you want to can you, what have you found? What have we found for the first one? For the 71? What? Okay, 35%. What? 18%. Okay. For the other one? Or arithmetic mean 1%? Negative 36 point something percent. You are, of course, you are totally at a very, very big loss. Because when it was 50-50, I think at first when it was 50-50, that was, I think we had another scenario. Now let's proceed. Let me just interpret what is happening there so that maybe we can, this answer of 0%, the answer of 0% to retain actually measures the fact that there was no change in wealth from the investment over the past 2 years. That's why it was 0%. So if you look at the 0% that you got, where? Here. All right? Here. You got, the fact that you got 0%, what it means, there is a meaning here. Why the GM is 0%? It means that there was no change over the years. That's why you had this one. So there was no change here. So you look at this one, there was no change here over the past years. That's why you had that this is 0%. But had it been that maybe you had other changes like negative, what would have said maybe there was a sort of like positive and what? Yeah. All right, so you can see that we are having the 0 because there was no change. It's as good as you deposited that money, the interest you are giving, but when you take them back, it's as if maybe there was nothing that has happened here. It was just a constant. That's why you got a 0%. That's something like that, right? Now, if you look at what they are saying here, is that when the rate of return are the same for all years, the GM is equal to AM. So if the rates of return vary over years, the GM will always be lower than AM. But the difference in two mean values will depend on the year-to-year changes in the rate of return. Larger annual charges or larger annual changes in the rates of return, that is more volatility, will result in a greater difference between the alternative mean value. So the volatility, that difference now. So what they are saying that assume that GM is equal to AM. What does that mean? It means when the rates are the same over the years, then the GM will be like that. For example, let's look at AM, the scenario where you have got AM equals to GM. AM, where there is AM equals to GM. AM is equal to GM. All right? The answers should be the same. The answers should be the same. All right. Let's look at this one. You have deposited 50 and you are getting 50 here. You are taking that 50, you are bringing it here, again here 50. Calculate AM and GM for the 2 years. AM and GM. Which means here, let's do together. This one is equal to 1, all right? And again here is equal to what? 1. So here is equal to 0, right? And here is equal to 0. Let's calculate this one. Here, let's calculate that. Let's calculate that. Let's calculate that. Here, HBY add 0, right? It's 0, all right? Divide by that's 0, right? Here, you multiply. 1 times 1, 1, right? To the power 1 over 2, which is the square root of 1, which is 1, all right? Right? So 1 minus 1, which is 0. So you can see that AM is 0, GM is 0. That context, There is nothing that has changed. You got the money, it's as good as just taking the money you invest, you are getting the same, something like that, right? So in that scenario, it's the same. That when the rate of return are the same all for all the years, the GM will be equal to AM. When the rate of return are the same to all years, it means that the AM is equal to the GM. But if the rates of return vary over years, the GM will always be lower. GM will always be lower. Let's look at it. GM is always be lower. This is always lower than this one. All right? Always this one is lower than that one. In that context, but the difference between the two mean values will depend on the year-to-year changes in the rate of return. All right? So, an awareness of both methods of computing mean rate of return is important because published accounts of investment performance or descriptions of financial research will use both the AM and the GM as a measure of average historical return. What they're saying is that both the AM and the GM are very, very important. Although we are saying that this is more superior, but both are very, very important because they're saying rates of return using weighted means. So rate of return using weighted means is what we are going to look at more. Today we have looked at several elements. We have calculated arithmetical mean, geometrical mean, and we have interpreted what are these geometrical mean, what are those arithmetical mean, and we have seen what are the advantages, what are the disadvantages of these two modes of measuring the return. So we have seen which one to use, which one to use. So we are finishing here and say that then we will continue with the topic of calculating the expected rate of return using the weighted mean, which we are going to do that tomorrow. I think let me finish it.